Hi, welcome to this webinar. My name is Susana Carneiro. I'm currently the Executive Director of Centro Pinus, that could be translated to English as Pine Center. And we are a Portuguese NGO focused on pine. So in Centro Pinus, we are always striving to learn more about pine silviculture. And one of the obvious ways to do this is to reach out to colleagues in other parts of the world and ask them to share their knowledge and experience with us. We realize other foresters and researchers could benefit from this. And so we decided to promote an international webinar series that has the aim to identify international success factors in pine silviculture. We found in IUFRO the ideal international partner for this, particularly through the Ecology and Pine Silviculture unit. And I invite Teresa Fonseca, that will be addressing you as the coordinator of this unit, to make a short presentation about IUFRO. Hi, Teresa.
Hi, good afternoon. Welcome to the first session in the series of webinars organized by the Pinus Center and the IUFRO Forest Ecology and Silviculture Unit of Pine. For those not familiar with IUFRO, this is an international organization of forest science research institutes with about 600 members from more than 100 countries. A summary will be shared with you through mail tomorrow. I thank the Pinus Center and its director, Susana Carneiro, for the challenge launched to co-organize this cycle of events. And I would also thank Professor Peter Spatelf for his availability to share with us the results of research on the Scotch pine. On behalf of our unit, on behalf of my fellow delegates, I wish you all a good session. We will remain available for any clarification about IUFRO and about unit. Thank you.
Thank you, Teresa. So now that we presented the cycle, let's focus on today's webinar. For today's webinar, we looked for a German co-promoter. More specifically, I need to read this, the Eberswald University for Sustainable Development. And we are going to focus specifically Scots pine management in Central Europe. So this is a Zoom webinar, and the audience won't be able to turn on their cameras or microphones, but we do invite you to participate. You are invited to send questions and comments through the Q&A icon that I invite you to identify at this moment. So our speaker will be making a presentation, and I invite you to make these comments during the presentation, because we agreed specific times that we make a short pause so that we can introduce a few questions. So the presentation will be sent to you via email. And now I would like to present today's speaker, Peter Spatelf. So he is a professor of applied silviculture at Eberswald University for Sustainable Development. And after having studied forestry sciences in the Freiburg University, he entered the State Forest Service. He finished his PhD in 1997 in University of Freiburg. And after that, he went to Brazil, and he was a lecturer of German Academic Exchange Service at the Brazilian Federal University of Santa Maria. That's why he speaks Portuguese. So the three of us can speak Portuguese, even though we are addressing you in English. So after that, he was a dean of the Faculty of Forest and Environment at the Eberswald University. And moreover, he is in charge of climate change and forest adaptation with the German Forestry Association. Peter, thank you so much for making the time to share your expertise with us. and I invite you to start your presentation.
Thank you, Susanna, for introducing me. I hope you can all hear me. So
Perfectly.
I will now share the presentation screen with you. And I hope you can see me, you can hear me. So it's a great pleasure for me to start with the first webinar on pine species. So Scots pine will be the focus of the lecture today. And my title is The Management of Scots Pine for Resilience from a Central European Perspective. And just a moment, I still have a problem. Okay, now it's working. I will have this lecture today and I will remember our Ukrainian colleagues and friends. As you may know, we have strong relationships from Eberswalde to the National Forestry University of Ukraine in Lviv, or Lemberg in German. And we have a lot of students and friends and colleagues there in this very difficult time. So, and I will start with some pictures, dear students, dear ladies and gentlemen. When I walk through the forests near Eberswalde or in northeastern Germany, I see many signs of the current practice and the history of Scots pine management. These signs of resin extraction, a practice which was common in Eastern Germany until 1990. I see memorial stones, such as the stone of Georg Ludwig Hartig, who was the inventor, so to speak, of the large-scale shelterwood cutting system and brought this into the pine forests of Eastern Germany at the time. And I see declining Scots pine trees as a consequence of the latest heat and drought years since 2015. And what we also see when we walk around near Eberswalde or in the northern German lowlands in the pine forests, we see damaged forests and salvaged areas, and the foresters who try to reforest these areas again and to try to re-establish a hopefully more resilient forest for the future. So the outline of today is I will talk about some basic features of Scots pine forest management in Germany. So ecology, some aspects of growth and the climatic robustness. I will address silvicultural systems of Scots pine forest management. I will lay a focus on the question of high value timber production, because I'm a silviculturist and I'm interested in producing valuable timber and other ecosystem services. We will discuss with you the question whether Scots pine is an appropriate or a suitable species for continuous cover forestry, as continuous cover forestry is worldwide a very important alternative to clear cutting systems. And then I will go ahead with some explanations or some arguments for the management of Scots pine forests for resilience. All right, so first, let's go ahead and look at this species. You may all know that Scots pine is, after juniper, the second most frequent conifer species in the world. It invaded in the post-glacial period as one of the first tree species. In Europe, Scots pine forests now exceed 28 million hectares. So they represent around 20% of the productive forest area. So a very significant tree species. And you can see that it grows from sea level, from the Nordic countries to higher altitudes in the Mediterranean region, for instance, but also up to 2,500 meters in the Caucasus. And it's also planted and cultivated in other countries, for example, in Northern America, and there it is called Scotch pine, but we say Scots pine in Europe. All right. What about the distribution in Germany? So in Germany, we have, according to the National Forest Inventory, the last National Forest Inventory from 2012, the next one is under preparation, and we will have the data in 1 year. After the NFI in Germany, Scots pine has 3 focal areas. The first is in northeastern Germany, so in the Berlin-Brandenburg area or Saxon-Anhalt federal state. And then we have a significant Scots pine distribution range in the valley of the Rhine River. And then Bavaria, the center and northeast of Bavaria, is a very old area where Scots pine is cultivated. And an interesting detail here, the first artificial regeneration in Germany with Scots pine was direct seeding or sowing already in the 14th century. So in 1368 near Nuremberg, that was the first place where Scots pine was sowed by foresters. So 3 areas in Germany, and you already imagine or can see these areas are currently quite vulnerable to drought stress and the changing environmental conditions, especially the valley of the Rhine River and northeastern Germany. So what about Scots pine as a species? Something you may know very well. It's a 2-needle species. It can grow up to 700-800 years. So we know that from northern Scandinavia, such old trees. It's wind pollinated. It's normally monoecious. Natural Scots pine stands in Germany. Natural stands are quite restricted to extreme sites. For instance, mires, also shallow rocks and the soils on these sites, and very poor sandy soils. For instance, on sand dunes, we find natural Scots pine. And in Germany, it's around 10 to 20% on the sites. We have naturally Scots pine. But as you know, in forest history in the last centuries, due to cultivation as a result of land use, we have an extension of Scots pine to an area of 50 to 60% in some areas of Germany, especially in the northeast. If we go a little bit into ecology, we can see that Scots pine, the realized niche, so to speak, so the ecological amplitude in terms of the realized niche is near the margins of forests at the dry end or the dry margin, and below, you see it on the Ellenberg ecogram, and below also on the wet margin. So that means that is something each student knows in the first or second semester, that the realized niche Scots pine is restricted due to competition of more competitive species such as European beech to these extreme sites. If you look at the physiological amplitude, so the fundamental niche, you can see that Scots pine would also grow, of course, without competitive tree species or tree species excluded, competitors excluded, in the center of normal sites, fresh sites, moist sites, and from their nutrient content, very rich sites. So that is the ecology of Scots pine, the realized niche. If we look at the successional stage where we find this tree species, we are of course aware that Scots pine is a pioneer species. It's an early successional tree species, so it's light demanding. Yeah, it can colonize recently disturbed sites. For example, if competition and grazing pressure is low. That is the reason why Scots pine sometimes is and was also used for restoration purposes, because it can colonize these very difficult sites. It has a quite pronounced drought tolerance and also a good frost resistance. It's quite undemanding as to site and water supply. So it's a light demanding species and so to speak, quite difficult to work with it under continuous cover systems. We will see that later. If we go to more details, the root system is more like a hard root or a tap root. So it's comparable to silver fir on the right-hand side of the slide. It has tap roots, very extensive, very long, and this leads to the fact that this species can be quite resistant to storm, and it's a species which is enriched to other forest development types or mixtures in order to stabilize these forests, especially it is added to Norway spruce and silver fir as a stabilization element. But on more shallow soils, on clay soils, when groundwater level is high, this species can also be vulnerable to storm. So it has two sides. And of course, we must take care
So I believe maybe there was some. Okay, go
yeah.
on, Peter. You were frozen for a few seconds.
Okay. I hope I can go on unfrozen.
Yeah.
Okay, so you can see the deformed roots, which should of course be avoided when you plant Scots pine. All right, let's introduce some growth and yield facts. If we look at total production over age, so it's a German figure, and you can see total production on the vertical axis over age on the horizontal axis. You can see at the reference age of 100 years in northeastern Germany, Scots pine yields 8 cubic meters per hectare and year. So 800 cubic meters of total production in 100 years. So it's a quite performant tree species, but it's far below, for instance, silver fir and Norway spruce and even Douglas fir as an introduced exotic tree species, which performs very well and is maybe 100% higher than Scots pine in terms of total production. Okay, recently many groups, many colleagues at different research institutions and universities were working on the growth and yield of Scots pine in mixtures and the performance of this species when it is admixed to other trees or tree species. And I will report some results here from Hans Bretsch, who for a very long time did excellent research, and his team at Munich University on this effect he calls, or is called in the textbooks and in the articles, over-yielding. And the results are stunning. You can see here the standing volume in mixtures, especially with beech, is more than 12% plus. The stand volume growth is increased compared to the weighted mean of the neighboring monocultures. The explanation is quite interesting. There were many interesting results or research ongoing how this can be, how there could be such a multiplicative effect and not only the additive effect of two species on their compartments, but it's a kind of emerging characteristic or a multiplicative effect. This is due that in a mixed stand, the packing of the trees per area can be more efficient. So there can be more trees with a specific size in diameter, for instance, per area than in a respective monoculture. So the package of the trees is better, and that leads to a higher yield. So this over-yielding is reported in many studies, not only in the combination of Scots pine and beech, but also in the combination of Scots pine and spruce and other combinations. The interesting question, is it dependent from site conditions? So if you do this analysis along a site gradient, sometimes there are positive results, sometimes there is no influence. But I found one interesting correlation. It's here a correlation with the Dematon index. So with decreasing drought, there is a decreasing over-yielding.
Peter was a bit frozen.
So okay.
Go
All
on,
right.
Sorry.
So it's
froze for the few
maybe
seconds.
it's also it can be seen what is illustrated here. All right, so I go just further on with this relationship again, which shows us the over-yielding effect. You can see on the graph here that the productivity and site quality and the species richness is related with each other, and the lower the site quality is, the higher is the productivity increase when species are admixed, especially when you go from 1 to 2 or 3 species already. There is a significant effect. And we call this the underlying physiological processes is niche complementarity. So there is, especially if you combine light demanding and shade tolerant tree species, there is a complementarity effect on the better site spectrum, and on the poorer site spectrum, the physiological background is called facilitation. So two species help each other, so to speak. They facilitate the better uptake of resources, and thus it comes out such an over-yielding effect. Yeah, species, Scots pine. Let's compare it with other pine species. Let's go abroad and look at comparable pine species. We have 111 pine species on the world, and in the webinar cycle, further pine species will be addressed and will be explained. And if you go to the fast-growing plantation forest sector, for instance, in southeastern US, Pinus elliottii, taeda, you have very fast-growing and very performant pine species with yields of 25, 20 cubic meters per hectare and year. If they are genetically improved, even better. And if we go to Chile or if we go to New Zealand, we have radiata pine, also a very well-growing pine species. So this is plantation forestry. In Central Europe, we are in a kind of semi-natural forestry. In the public discussion, people very often talk about plantations. If they see a pure stand, it's a plantation, but we have to be careful. We have in Central Europe a tradition of mixture, and we have a tradition of working with natural regeneration. So I would be very careful to use the term plantation. If you go to the subtropics and tropics, you can see real plantations. If we look at the response of Scots pine, there's a lot of studies, of course, and we should look at 3 growth parameters: the height, the diameter, and also the yield per area. And what you can see in this thinning response, you see on the horizontal axis the density. So from a maximum density going down left to a minimum density. And what you can see, if we reduce density in terms of height, we do not have really a response. So it's very, very poor, sometimes not significant. But if we go to diameter, of course, we can see a very strong positive response. This is, of course, we do silviculture, we intervene in forest, we create more light conditions or better light conditions in a stand by thinning. And this means that especially the diameter growth is accelerated with heavy or intensive thinning. And in terms of yield, we have a slight negative effect if we reduce density. So we lose a little bit of yield in terms of volume, of cubic meters of volume per area, but instead we gain a lot of diameter increments. So we are able to produce a tree, a thick tree, in a shorter period of time, and maybe we reduce, therefore, the risks to climatic conditions, etc., by doing this. That's an important argument. So this is the thinning response. It's called Assmann's theory. This is a relationship which you can more or less find also with other tree species. All right. What about pine wood utilization? Let's address it briefly. So the pine wood, you can see here a cross-section from our university, is very easily workable and is one of the strongest softwoods with a very good strength to weight ratio. The wood contains resin and has a very good natural durability. So the timber, the pine timber, is good for pulp and paper, for fiber boards. It's good for furniture. It can be used for building and construction, and it can even be used, of course, for so-called engineered wood. Again, industrial roundwood you can see here on the piles, and here on the right side you can see a kind of engineered wood, so the glued laminated timber, which allows us to take small dimensions and glue them together to larger entities or larger units for excellent building and construction purposes. I want to tell you just a story from Eberswalde, from the former GDR, in terms of resin, in terms of the production of this non-wood forest product. I heard from a a forester who was responsible before 1989 in the former German Democratic Republic. He said that in the state forest enterprise of Eberswalde, there were 70 resin workers who only had the job or the task to extract resin, and they had in the plan the task to extract more than 300 tons of resin per year in one small forest district. So non-timber forest products do not play a very significant role at the moment in German forestry, but in the past, it was much more significant. And in other areas in the world, these non-timber, non-wood forest products are really essential, an essential ecosystem good which forests provide. If we go to a more detailed analysis of provenances, we can see that some provenances on the left part of the figure are more vulnerable to storm damage. So the bars are the intensity of storm damaged wood. Especially the German and the Western European provenances are more vulnerable, and the Baltic and the Eastern German and the Latvian provenances are much more resistant to storm damage. That is something we know from provenance trials or common garden experiments. And what we all know from this international provenance trial in Korin near Eberswalde, the quality and the growth of these provenances. You can see two provenances, the Baltic provenances, Masuren, it's Poland today, and you can see the French provenances. The French provenances are very bad in quality and also inferior in growth, whereas the Baltic provenances grow very well and have a good quality. On the other hand, recent research shows us that especially the French provenances are very resistant to drought because they have specific substances in their tissue which allows a high drought resistance. So it's a trade-off, as you can see. Provenances can be very good in terms of growth, in terms of quality, but on the other hand, they can be inferior in terms of resistance and susceptibility to climate change factors. We must be very careful in the selection of these provenances. All right. The vulnerability of pine came up really in the last 5 to 6 years, especially after the drought event in 2015 in Germany, and of course after the cumulative drought years of 2018, 19, 20. We see a lot of damages. The right slide is damages in the Bavarian area, and the left slide is a typical insect damage in pure pine stands. And pine, of course, Scots pine and pure Scots pine stands are very susceptible to many insect damages. So the pine tree lapid moth or gypsy moth, they often lose nearly 100 or 90% of their needles and sometimes cannot recover anymore. Sometimes they can. So that is typical for pure Scots pine management. And today we know perfectly that especially mixture is reducing this risk substantially. If we go a little bit more into this question of susceptibility of pine to drought stress, to negative climatic factors, we have to go to Switzerland first and look at the Swiss results in the inner alpine dry valleys. From the colleagues there from the Swiss Federal Institute of Snow and Landscape Research and Forestry, we know that pine trees in the inner alpine dry valleys of the valley of the Rhone and the Vinci, it's in northern Italy, we know that pine is declining in the lower elevations, and downy oak, Quercus pubescens, is gradually substituting pine there. So we have a kind of species substitution in a margin area of the pine distribution range. That is what we know from the Swiss colleagues. If we go more into detail in pine in its physiological properties and characteristics, we have to say it's an isohydric species. So pine responds to drought very quickly with stomata closure. That means it stabilizes, the tree stabilizes its water potential, but on the other hand, it cannot uptake sufficient carbon anymore. That means it is vulnerable to carbon starvation on a mid and long term. We know from these nice experiments in Switzerland the role of the ground vegetation. The vegetation is consuming very much water there, so it has to be removed. The trees can be stabilized by thinning. And we know also, that epigenetics play a role in the so-called acclimation of trees. So we know this from interesting studies in Switzerland where the offsprings from control trees which were exposed to drought were more tolerant to heat and drought conditions than the offsprings of irrigated trees, and they did not have any genetic difference. So there's a kind of epigenetic influence there which acclimates trees better to a specific environmental factor. The explanation or the conceptual approach to explain the decline of drought is quite well known. So it's the spiral model of tree decline. It can be applied also to other tree species, to oak. It's very common, also commonly applied with oak. And you can see there are disposing factors, maybe unsuited sites. There are triggering factors which start a decline process. And then third, there are reinforcing factors which aggravate the declining process. Reinforcing factors, for instance, are the insect calamities. If the trees are stressed by drought, of course, they are much weaker and insects can attack, and finally there can be a damage. That is the spiral model of tree decline. An interesting question concerning pine, also Scots pine, is what is the role of fire in Central European Scots pine forestry? And one could imagine, or one could argue or think that fire could also be a shaping factor or molding factor in pine stands. But this is not the case for Central European natural pine stands, because as I told you, natural pine stands grow on very shallow, very poor sites. So there is no accumulation of litter, which should be kind of burned to release the nutrients in this litter and to start a renewal or reorganization process of the stand. This is not the case in natural pine stands in Central Europe or in Germany. So fire is not a shaping factor, but fire, of course, occurs. The number of fires in principle is slightly declining, but we have some special years, of course, 2003, 2018, with a lot of fires, with large-scale fires on former military training areas in Germany, where ammunition is exploding and is igniting a fire. Yeah? And such a fire you could see south of Berlin in 2018. It's an area with nearly 400 hectares. And it's a nice area to study the reforestation process. And there's a large research project ongoing there, which is coordinated by a colleague at Eberswalde University to study the aspects of reforestation, of natural reforestation, the role of deadwood, etc., the role of soil scarification and other techniques to improve the reforestation. So with this, I could, as we planned, have a small break and answer some questions if you want.
Yes. I will like to acknowledge that your students are very lucky because your presentation is being very clear. I totally agree with several of the comments that you made. For instance, that in Europe, at least in Portugal, we don't really have plantations, and people tend to call it plantations. And I agreed with that perspective. We already have 2 comments and questions. I will address them, but I also have some questions. I wonder why is not resin production, why it has stopped? Because here in Portugal, for instance, and Spain, it is the opposite. There is an increasing interest in this. Also, I wonder what is the dynamics for the area. Is the Scots pine area stable, or has it been declining? And what is the typical rotation? Sorry to make you all questions at the time, but they are fast answer questions.
All right, resin. So in Western Germany, where I grew up, there was no, I cannot remember resin production or resin extraction. But in Eastern Germany, it was a practice until 1989. And this had to do with the socioeconomic conditions of the GDR economy, which was an economy under pressure to produce as much in the own country, so on the domestic market, and not to be able to import everything. So it was a typical thing, and the people told me that not only resin production was a typical characteristic of the forest enterprises, they had a specialization in many other things apart from forestry, because they tried to produce as much on their own due to the difficult situation in the general economy. And this stopped completely with 1989, with the entering of Eastern Germany onto the German market and the world market and the substitution possibilities. The area of Scots pine is declining. In northeastern Germany, we have 50 to 70% of Scots pine forests, the share at the total forest area. And as I told you, 10 to 20% is the natural share. So this share or this amount of Scots pine forest, they will be converted. They are already converted and will be further converted in the future into mixed stands. Sometimes we will even abandon Scots pine in the stands and convert completely into a broadleaf mixed stand when the site conditions are too good. When we have very rich sites, it's not appropriate to plant or to have Scots pine anymore. So that means it declines, and our timber industry is already asking us, will we have enough Scots pine timber on the market?
That's one of the questions I had for you, because there's a severe wood deficit specifically for hardwood, softwood.
The softwood sector. So that is a question of wood supply. That is not my primary question as a silviculturist, because my task and my interest is to develop resilient forests for the future. And these are mostly mixed forests. And of course, these forests should contain also conifer tree species. We should not do this fault and substitute all our conifers. So we have a very fragile species, which is called Norway spruce, which is very under pressure. We have Scots pine, which started to decline in some areas. And we have Douglas fir, which is under suspect because it's an exotic tree species. And Douglas fir at the moment has a share in northeastern Germany of 1 to 2%. So it's quite restricted to just a few spots. So that means we will lose Scots pine, but we should keep some conifer tree species, also for stability reasons, but also for wood supply reasons. And all the architects and the wood technologists, they tell you in simple words, you really cannot make a good construction wood out of beech. It has too many difficulties. We must have conifer or softwood tree species. So the rotation, the last question, the rotation of Scots pine is 80 to 100, 120 years. It depends on difficulties with fungi, which may come up at the age of 90, 100, etc. So the rotation is restricted when the target diameter is reached. The foresters start, and that is the next slides we will see, start to regenerate the pine stands by shelter wood cutting or by irregular shelter wood, etc. Thank
you. So perhaps now we can look at some questions in the chat. Could it be that high density is answer to drought sensitivity of coniferous? Sparse stands are in less competition for limited water resources. Is a comment about I believe the situation in Switzerland that you were describing.
So it's a comment. It's not a question. Or
it's a comment.
Okay.
It's a comment. And we have a question that high mortality of pine in Germany during a drought in 2018 and 2019. That drought could, it was responsible for the high mortality. I will guess so. So I'm sorry, but I didn't get the chance to see the comments that people were making during your answers. So maybe you could go on, and we will address them in the next break.
Okay, thank you.
And I will read them.
Okay, so we go to silvicultural systems now. We have the group of the uneven age systems or the continuous cover forest systems, so with irregular shelter wood and selection forest. And we have the even-aged silvicultural systems. And we must say, pine, Scots pine, is still in many cases regenerated with even-aged silvicultural systems. So by clear cutting, still it occurs. We will see examples. By shelter wood cutting, it's still common, not large-scale shelter wood cutting with several hectares, but small-scale shelter wood cutting, and also with strip cutting. So we have a focus still on the even-age silvicultural systems. And this is an example of that. Yeah, this is a clear cut in northeastern Germany, in the federal state of Mecklenburg-Vorpommern, and it's more than a hectare. And of course, we have restrictions, legal restrictions in Germany, in the federal states, with respect to clear cut. Normally, a clear cut in Brandenburg, my state, where I am working at Eberswalde, the clear cut is there when you reduce the stocking volume below 0.4 on more than 2 hectares. Yeah, then you have a clear cut, and this is not allowed. Yeah, so clear cut is restricted, of course, by law, by forest law, and it is restricted also by certification. By forest defined methods or even more individual approaches. So that is clear or strip cut. Much more common is shelter wood cutting. You can see it here on this slide, a stand near Eberswalde. We all know the stages in shelter wood cutting. It starts with the establishment cut, and then we have successive shelter wood cuttings, and the stocking volume is removed gradually and uniformly over the whole working area in order to promote the natural regeneration in the understory. That is shelter wood cutting. And this system, by the way, was brought to northern Germany at the beginning of the 19th century by Hartig. You remember the memorial stone I showed at the beginning. So this is shelter wood cutting, another popular silvicultural system with a Scots pine, or which is applied in Scots pine stands, is the seed tree system. This is a picture from Norway, because the seed tree system doesn't really exist anymore in Germany. It existed in the GDR. There was a kind of seed tree system which had even an agroforestry component in it, but it was abandoned. It doesn't exist anymore. And today the seed tree system, we can see it in Scandinavia. So when 30 to 50 seed trees were holed over in order to provide the seeds for the regeneration, and then after the establishment of the new forest generation, after 5 to 10 years, the seed trees are removed. What we sometimes find in German forests are holdover trees, but it's not a typical seed tree system. So, and then Scots pine can also have, as a tree species, can have service functions. We know many systems where trees have service functions. For instance, the mixture of lime and hornbeam with oak in order to provide shade and to avoid the growth of epicormic branches at oak, which is a factor which is devaluating the timber or downgrading the timber. That is a trainer species, lime and hornbeam, and a service function of Scots pine is also with the nurse crop. When we take Scots pine as an overstory, a temporary overstory. For instance, in the reforestation activities on large-scale clearcuts, where we provide these nurses or these nurse crops, and then in the protection zone, so below the overstory, the target tree species can be planted or can grow, can germinate. Yeah, that is exactly the description of the nurse crop. And the function as a pioneer crop of Scots pine is very common. So what you can see in these forest conversion activities, you very often see the first generation or even several generations now was Scots pine, and now more broadleaf tree species or more other target tree species are planted or introduced under the canopy of these Scots pines. This is the case in many forest stands in Germany where beech and oak were planted or sowed below the canopy of Scots pine. This is an example from Bavaria. And another example I show you from the subtropics, from Misiones in Argentina, where a pine species is a nurse or a protection shelter for the more valuable mahogany tree species in the understory. So pine has a really central role in these early colonizing species on difficult ground, in areas of a harsh microclimate, in order to initialize a forest succession process. When we talk about silvicultural systems, we must mention the retention principle and the retention systems. And I think retention and the introduction of the retention principle, or the expansion of the retention principle into different areas of the world, is a very good progress, because it is a nice alternative to clear cutting. The focus is shifted from the trees to be removed to the trees to be maintained in a stand, so to speak, to be retained in a stand. And when we look at clear cutting, of course, there's 0% retained trees. If we look at seed tree system, we have maybe 5 to 10% trees in the overstory. And if we look at shelter wood cutting, we have a higher degree of retention. And the retention principle was, for instance, introduced in Northern America as a very important measure to implement the ecosystem approach, so to speak, to shift from the clear cutting practices to a more ecosystem friendly practice of forest management during the 1980s and 1990s of the last century. So retention principle, a very promising approach to work more close to nature in forestry. Now let's look a little bit to natural regeneration of pine in northeastern Germany. It's a case study, and I show some slides just to give you an impression where Scots pine still is cultivated, or Scots pine still is grown. It's on the poor side spectrum. So we have 5 categories in Brandenburg. It's in the poorest 1 or 2 categories. Scots pine is the leading tree species still today. Yeah, and we keep Scots pine, we admix it with other species, and the procedure to renew the stands is by natural regeneration. And natural regeneration very often works. Sometimes there has to be a soil tillage, a slight soil scarification, in order to allow the small seedling to find access to the mineral soil. So this is important. Scots pine germinates on the mineral soil, and to have an abundant natural regeneration, it is good to have really just a small litter layer or even the bare mineral soil on the top. And then it works. You can have wonderful Scots pine regeneration. And in the following, you can enrich by planting in this forest district, South Brandenburg, a private forest owner who enriched his Scots pine mixed stands, totally regenerated naturally. Also the oak and the beech came in naturally, but he enriched it with Douglas fir. So he planted Douglas fir or in wide spacings every 10, 15 meters, some isolated Douglas firs, to add another conifer tree species, which has good characteristics, which is a good species to work in close to nature systems. It's growing well, and it has quite some good characteristics in terms of climate robustness. And the mixture question, I think we are all familiar with the advantages of mixed stands, but we all know that mixtures have to be promoted. So we have to very often intervene in forests. We have to conduct intermediate cuttings to maintain mixtures. Otherwise, in many cases, if we have dynamics among tree species with less vigor will be overgrown and outcompeted by competitively strong tree species. So we have to do something for mixtures. And that is a reason why I advocate forest management in order to establish climate resilient stands, because mixtures we can promote with management. And we have different possibilities to create mixtures in a very good textbook written by Jürgen Bauhus and colleagues. You can find all the information ecologically, but also in terms of silvicultural management with respect to mixtures. So you see the naturally regenerated stands in Brandenburg with pine on the poorer side spectrum. It works quite well. I have to add here one fact. It works quite well if deer populations are very low. So in Germany, we have still in many forest districts, we have too high deer populations. They are not adapted to the habitat structure. So this is still our task and our duty to reduce deer populations to a habitat adapted level. It's a long story which cannot be explained completely in this lecture. But it is a fact in these forest districts which work successfully with a diverse natural regeneration. They all hunt very efficiently. So they have the deer populations under control. And this is exactly the fact also in this forest district, also a private district south of Berlin. So natural regeneration of Scots pine, it works. You find several thousands of trees per hectare, yeah? And you are able to select among the young trees. You easily find so-called future crop trees you can identify, you can release for initiating a production of good timber. That is no problem. We have worked on that also in students' master and bachelor theses. Okay, so with this small overview over the silvicultural systems and Scots pine management, I go to another silviculturally very significant and relevant topic, which is the production strategies. Before we come then at the end of the lecture to ecosystem services and climate resilience, I want to first highlight the process we are in at the moment. So we are experiencing a shift from the mass production goal to the goal of high value timber production. That means our interest is not to produce as many trees as possible per hectare with intermediate diameter, but to produce large trees with a large diameter, thick trees with a very good quality. So this high value timber production strategy is really a competitive advantage of Central European forestry. I think we are aware that we may not compete with pulpwood production with the tropics and the subtropics, and maybe with other areas in Europe. But in terms of high value timber production, we have the tree species, we have the concepts, we have the sites, we have the silvicultural approach, which is continuous cover forestry. So it's a very promising, a very interesting goal. And interestingly, in Germany, we have an association of close to nature forest enterprises. It's called ANW. Interestingly, these forest owners, very often private forest owners, they are very much committed to high value timber production. And they also use exotic tree species, so Douglas fir. Okay, so the target is the large tree with high value. And for managing these stands, we have to remove bad trees, inferior trees in thinning procedures. So the management of pine stands for high value timber production follows this circle of silvicultural practices. After having regenerated a stand, we very often have to intervene in stands in terms of a pre-commercial thinning. That means we reduce the stem number, the density, or we make a mixture regulation. So we release tree species under pressure, or which are may be overtopped. That is pre-commercial thinning. And then we thin. We have several cycles of thinning, of intermediate cuttings. This is contrary to the direct regimes in plantation forestry in the tropics and subtropics, where the trees are planted and after 10 years harvested without intermediate cuttings. And then we quite often, not in every case, but sometimes we prune. We artificially prune the trees, the future crop trees, because the removal of branches is essential for producing high value timber. Otherwise, with conifer tree species, it's not possible, because conifer tree species, they keep their branches. Even if the branches die, get less vigorous, they will not fall down, and you will have a wood or timber with a very large knotty core if you won't prune them. So that is important. What we don't do, of course, is fertilization. In close to nature forestry in Central Europe, fertilization does not play any role. And then finally, we have again the harvest and the application of silvicultural systems. So the crop tree concept is very helpful to increase effectiveness and efficiency of forest management. Because if you identify and release future crop trees, you can concentrate the growth on vigorous and qualitatively good trees. You will reach the target diameter in a shorter period, which reduces also, by the way, the risks of production. So it's a very effective and efficient measure or approach in forest management. You can work in mixed stands with future crop tree selection. So you select different tree species and release them continuously every 10 years. So the intervention cycle in Germany is every 10 years, sometimes every 5 years. That is future crop tree selection. The selection of a future crop tree is according to vigor and quality in this ranking. And if we then look at the whole concept of high value timber production, we can see that is a two-stage concept. You can apply it, by the way, on nearly every tree species, but you have to adapt it in terms of rotation, in terms of pruning, yes or no, but you can adapt this two-stage strategy of high-value timber production to all tree species in every ecozone in principle, not only in the temperate zones of Central Europe. The first stage has to do with quality. So in the first stage, the focus is on quality. That means the stands are rather dense. That means natural pruning occurs quite easily. And then we can see which trees may have good qualities and which trees are the most vigorous trees. In the second stage of this very interesting concept, we have to shift our focus and have to release the future crop trees. We give them more standing space. We take out, we remove competitors of the future crop trees. And with that measure, we increase the diameter increment. We accelerate even the diameter increment. Remember the figure I showed to you, the density reduction and the impact on diameter increment. It's a very relevant response, which we as silviculturists use when we manage forest stands. So that is the second stage. It's focusing on diameter growth. And the people work on the future crop trees, especially. Sometimes they also intervene in the parts in between of the future crop trees, but that is another story. So that is the concept of high value timber production, which is applicable also for Scots pine, of course. And what I mentioned, that if we work with Scots pine, we have to prune if we want to produce this high value timber. What does that mean, high value timber? That means, look at these nice stems here of Scots pine. These stems are free from knots, free from branches in the basic section of the stem, maybe 6 to 8 meters height. Yeah, they are free from branches. The branches were artificially removed by handsaw, yeah, mostly. And then the trees are released. They are released by the foresters every 10 years. 1, 2, 3 competitors are removed. And this accelerates the diameter increment and finally leads to a very qualitatively very good tree. In northeastern Germany, we have the experience, these trees with that excellent quality, it's in Germany, it's the quality A, they have a price twice as high as the normal assortment. So you can generate really a good income and a good profit with producing high value timber. But we have to admit the percentage of high value timber at the total timber of pine which is produced in Germany is maybe 1 or 2%. So there is room for improvement, a lot of room for improvement. So that is high value timber production. And one aspect I also want to mention here is, of course, it's not only about thinning and releasing trees. We have also to take care about the harvesting and the logging practices. What is happening is that we quite pay attention while harvesting on the remaining stand and the soil. So it's a kind of reduced impact logging strategy we apply. Reduced impact logging first means the forest must have roads so that machines can drive into the forest, harvesters can drive there, and the forest, the stands must have skidding lines. So every 40 meters we have these access lines. The drive over is only permitted on these access lines. So maybe 10–12% of the stand area is affected by maybe compaction. Yeah, that's right. But this is important to harvest maybe 5, 6, 8 cubic meters per hectare and year, which is the case in Germany. So the harvest intensity is quite high, although we are still below the increment level. So we may harvest 70–90% of what is growing in our forests. But it's quite a high intensity, which is not possible anymore with motor manual systems, only people working in the forest. So a certain degree of mechanization is possible. And what you see here on this slide is really a very heavy machine. It's not a standard machine, it's a harvester. And this harvester is able to take out the trees standing. So he cuts, or it cuts, the trees and takes it out standing, and that means without damaging the undergrowth, the underplanted beech, because this stand you can see here is in a phase of conversion into a broadleaf mixed stand. And in order to reduce the damages or to even avoid nearly the damages at the remaining stand, these machines are used. So reduced impact logging is a whole package, if you want. We must apply in close to nature forestry or in continuous cover forestry. As working in these forests, you must imagine you cannot see very far. You have a lot of understory. You have different tree species. So working in these forests is more difficult. It's more sophisticated, but it's necessary to manage these forests like this. All right. So here we could have other questions.
Yes,
we have still 45 minutes
okay.
when I look at the watch.
I admit I have a lot of experience in moderating webinars, but usually I already know what the speakers are saying, so I can read the comments and the questions at the same time, but I'm finding it difficult to do it now. It's very interesting what you showed us with this logging system, because I was, when you were speaking about these mixed stands, I was wondering all the time, but how do you harvest without managing the other species and without managing I'm sorry. Without, I guess my English is a bit
without damaging the other species,
the other species and
interfering,
the natural regeneration. And you have this system, and you also have quite a flat slope. For instance, because in some regions, in mountain regions and with the slope, it will be more challenging to have these kinds of systems. So what I would suggest is maybe we do take a 10-minute break. We read the comments, and you may select the questions that we are going to answer after those 10 minutes, and then we will go on further this presentation. Will you agree, Peter? That will be fine?
Yes, okay. So 5 to 10 minutes is okay.
Okay.
Yeah.
Okay.
Yep.
So see you in 10 minutes.
See you.
See you. So Peter.
Okay.
Have you decided with which questions? We have a lot of questions and comments, and this is really interesting. I think we don't have the time to answer.
No, I can address
all
2
of
or
them.
3 complexes, and then we go ahead.
Yes,
yeah?
but we do appreciate the questions and the comments, because they make this much more interesting. And then we will have, Zoom allows us to have a report of all these comments. So I invite you to keep making comments.
So should we continue?
I suggest that you may answer a few questions, and then we continue.
Yeah. Okay, so thank you for the questions. I read once more the question, why the mortality in Scots pine was so high since 2015 and especially 2018, etc. This is due to exactly this complex disease model or explanation. So we have several factors. It's not monofactorial. So we have several factors. We can have a triggering factor, which is heat. We know that especially in some areas of Germany, 2015, there was extreme heat, temperatures more than 40, 41 degrees. So Scots pine is not able to cope physiologically anymore with that heat. And then it's a triggering effect. The trees are losing vigor. And then, of course, you have all the biotic damages which occur. So insect damages attacking, or insects attacking less vigorous trees. And then other factors are coming on top. For example, mistletoe. Mistletoe is a plant which is also known from Switzerland as a reinforcing factor for damage of pine trees. And we observe the same in other parts of Germany. So it's a complex disease process which finally leads to mortality. And interestingly, we can see, if we look into the tree rings, if we make a dendro-ecological analysis with tree rings, we can see declining trees very often, or dying trees have also very small tree rings, 5, 10, until 15 years before dying. They are already in a decline process in terms of tree ring width. So that is the declining question. Another interesting question was, and we will have this also in the upcoming slides, is pine as a species, can pine grow for a long time in the understory of a stand? That is a difficult question. Normally, we know that shade-tolerant tree species, they have this capacity. So we know from silver fir can stay under the canopy of an old stand for 50, for 100 years, growing with very small tree rings, nearly visible anymore, and then after release, growing normally again. This is the capacity of shade-tolerant tree species. It's an essential capacity in a selection forest, in a truly uneven age forest, where you have a structured canopy with trees in the understory, with medium-sized trees, etc. For pine, this is more difficult. I would say, and I bring some examples, if we have a mature stand with a low stocking volume, so quite a so-called open stand, maybe with 100 or 200 cubic meters per hectare only, then we have enough light coming through the canopy in the understory also to allow young pines to grow and to survive.
Yeah.
That is a kind of adaptation of a silvicultural system which normally works better with shade-tolerant tree species. So that was an example. And then the question, eucalypt plantations in Central in Western Europe. Of course, if I look at Portugal, I think you have 20–25% of Eucalyptus globulus as an exotic tree species, and I would say these are plantations. Yeah. FAO defines plantations as regular stands, mostly with one species or two species, maybe with regular spacing, which have very often short rotations. So these are plantations, and Eucalyptus globulus
the point, the point wasn't to deny that we have plantations in Europe. It was the point was that sometimes we call semi-natural forests plantations. Yeah.
Semi-natural is a kind of attempt to
flexible
to establish a category between real plantations and natural forests.
Yeah,
so semi-natural, this was introduced by FAO, I think 20–30 years ago, to address this problem that we have forests which may have one species, but already have elements of
we lost better. Again, let's expect
natural regeneration invented. Yeah. Okay. Then there was one question, maybe was when can we select future crop trees? This is an important question. Yeah. You can select future crop trees when you can identify vigor with respect vigor of a tree with respect to its neighborhood and the quality of a tree. So in a kind of advanced stand stage, we can see how is the differentiation in a stand, where are the social classes maybe, and where are the vigorous trees with respect to its neighborhood, and where are the less vigorous trees. And this is normally at heights of 10–12 meters above. So we select future crop trees when trees have attained heights more than 10 meters normally. Yeah,
That's interesting. That's interesting, because here in Portugal we select trees from a natural regeneration stands in maritime pine quite earlier. And you definitely can tell which are the more vigorous trees. So that's quite interesting.
Mm-hmm. So this is already a quite early selection, and some people who criticize future crop tree concept, they say it's a determination which is too early, because we cannot be sure that a very early determined tree as a future crop tree will survive on a long term, yeah, because we have mortality reasons, different risks, best growing trees and the qualitatively best trees, but especially the most vigorous trees, they keep their advantage in terms of growth for a long time. So they do not suddenly decline. They just decline, of course, if there is a natural hazard, as a lightning or so, or a biotic attack. But normally they keep their advantage and they further grow very well. And that is the reason why we should select very vigorous trees, and by the way, also qualitatively good trees. All right, I think these were some of the questions, and if you allow, I could go ahead?
Yes.
And then we have a final session for questions at the end. Yeah.
Yes.
Because we have just maybe 30 or 40 minutes left.
Yes, but
okay.
There are a few slides that we agreed that you perhaps could speed up. So
okay. Maybe I can shorten also a little bit.
Yes, go ahead.
Okay, so yeah, just a moment. Yeah. Now the question of forest conversion. So how should we go ahead with conversion? And we must first acknowledge that forest conversion is already ongoing in Germany and in other countries also. Especially these countries which have a gap or a difference between the natural forest cover or the potential natural forest cover and the really existing forest cover. And Germany has a lot of spruce stands and has pine stands, and we have still, according to the last National Forest Inventory, we have 25% pure stands in Germany. So we have still the obligation to convert our forests into mixed stands. So the task is quite easy. We must come from the pure pine stands to stands mixed still with pine, if pine is a site-adapted tree species, but mixed also with especially broadleaf tree species, because the broadleaf tree species, the beech and the oaks, they are very important in terms of the potential natural forest cover. Yeah, most of the land in Germany would be a beech-dominated forest. So the potential natural vegetation, if human intervention would immediately stop, would be a beech-dominated forest on many sites in Germany. So beech is very competitive under the current climatic conditions. That means that beech is a natural tree species, of course, for the future mixed stands of or after forest conversion. Forest conversion is an interesting story. There was a landmark study done by EFI some years ago, the question of forest conversion. The book was called, and what you can see is the trajectories for forest conversion. And what we have to say that in Germany in 1913, the relationship of conifers to broadleaf tree species was 70 to 30. So we had quite an extensive period of conversion of the broadleaf forests of the Middle Ages and before into conifer forests during the whole period of settlement, of industrialization, etc., which is a longer story. We cannot comment on this. But we can see the development lines, the red lines from natural forests to cleared land, and the dotted line from natural forests to secondary forests of spruce and pine. And then we have also the green line, the conversion back of these secondary forests. And that is the correct term. The pine and the spruce forests in Germany are secondary forests. We can call them secondary forests, and they are already since several decades are converted back into more mixed and more natural stands. And that is exactly the task, which of course must go further on due to climate change. But it started already 1980, 1990 due to the insight in the susceptibility of these pure stands to all the kind of risks and problems and damages we all know. Yeah. So that is forest conversion. This is a stand which was for a very long time the mainstream forestry in Germany. So even-age stands, pure stands, especially in northeastern Germany, Scots pine stands, and in southern Germany in the mountainous areas, spruce stands. So these were the mainstream stands, and especially in the GDR, in the period of the German Democratic Republic, the focus was laid nearly exclusively on the maximization of volume production. So especially in the 1960s, 70s, in the GDR in Eastern Germany, it was essential for the foresters to produce as much timber as possible. And this was done in pure stands, sometimes clear-cutted on areas more than 20 hectares, so large-scale clear-cutting, and then planting with very high numbers of trees, so maybe 20,000 and more young seedlings per hectare. So that was the mainstream forestry in the middle of the 20th century, especially also in Eastern Germany. Yeah, and an interesting slide which I can show you here is a regeneration of broadleaf trees, or the mixture of broadleaf trees, which was practiced already in the 19th century, at the end of the 19th century. And you must look in the foreground. The old beeches in the foreground is a group which was established in a pure pine stand at the end of the 19th century in a kind of patch cutting. And that was an early attempt already at the end of the 19th century to convert pure stands into mixed stands, or to establish a mixed tree species component in the northern German forest stands. Yeah? So beech was introduced in these patches, and we can still see them today. They grew quite well and have normal quality, so it was quite successful, this method. What is very important as a technique, as a silvicultural technique today of conversion, is the so-called underplanting. We call it underplanting. It's either artificially, by really planting groups of beeches or oaks, for example, or rows under the canopy of a stand to be converted, or it is working with natural regeneration. Of course, we all know natural regeneration only works if the seed sources are available. So if mother trees are in the neighborhood, if beeches or other broadleaf trees are available, fine. But very often we can also wait for seed dispersal by birds, for example, by the jay. The European jay is very important as a seed disperser. So we have many stands in northeastern Germany where especially oak is accumulated in the understory as a natural regeneration, which comes from far distances, and the dispersal is done by the jay. Very interesting and a very close to nature approach. So we have these two types of underplanting and natural regeneration. That is beech, which is underplanted. It's the small figure or the small slide left, and the oak, which was dispersed by the jay. And with this strategy, many forest owners, and especially the state forest enterprises, they work with natural regeneration to convert these large pine forests, and also additionally with planting, with underplanting. Just to give you an example how expensive such a forest conversion measure is, imagine the conversion of a pure Scots pine stand into a mixed stand. We introduce 3 groups of beech and 1 group of silver fir with a size of 0.1 hectares in a hectare, under the canopy of Scots pine in a spacing of 2 by 2 meters. We need a protection fence because deer population very often is not low enough. So browsing intensity is still high, and to avoid browsing, one measure is fencing, as we all know. And soil scarification is sometimes necessary to eliminate the thick litter layers and to facilitate the germination of the pines. So what are the costs of such a hectare of underplanting? I gave you an example here, 6,000 euros per hectare. So you see, forest conversion is quite expensive. And to go into the future of these climate resilient stands requires costs and investments. It's not for free. Of course, we can work as close to nature as possible with natural regeneration, but sometimes the target species are not available, and then we have to plant. So it's an investment into resilience forests of the future we must take, and especially the forest owners must take. And for the non-Germans, in Germany, we have a high sector of private a large sector of private forest owners. So in some federal states, in North Rhine-Westphalia, we have 65% of private forest owners, sometimes small-scale private forest owners. And we have to help the private forest owners to realize this investment, especially to convert the forest and to reforest the damaged areas. And at the end, we can discuss some of the measures which are discussed at the moment in forest policy. So an interesting approach to manage an uneven age stand is shown in this slide. So forest conversion, ladies and gentlemen, is not only about mixing. Forest conversion very often is also about converting even age stands into uneven age stands and into truly uneven age stands. That means a mixture of different age classes or trees of different ages on a small area. And we all learn, we foresters learn that a basic characteristic of a truly uneven age stand is the negative J-shaped diameter distribution curve. You can see in the slide left above. So a truly uneven age stand has many small trees and then a few medium-sized trees and very few large trees, intimately mixed among each other. That is a selection forest or a truly uneven age forest. And conversion can also have to do with conversion into uneven ageness. And a very good approach here is the basal area diameter Q approach, which is extensively described in the forest growth and yield and silviculture literature. What you need is the basal area of the target stand, so the stand after intervention, and you need the Q factor, and the Q factor is the division or the relationship between the numbers of trees of two subsequent diameter classes. So the Q factor shapes the curve. If you have a Q factor of 1.2, you have a relatively flat curve. If you have a Q factor of 1.6, you have a relatively steep curve with a lot of young trees and small trees. Yeah. So with the basal area after intervention, with a Q factor and with the maximum diameter you want to achieve, you can establish a target structure of your stand, and you can derive the trees, the number of trees and the diameter classes where you have to intervene. So where the red arrow is in this slide, in this example, we have to intervene in order to come to the target diameter curve. That is an interesting concept. Maybe it's too fast to be explained, but if you are interested in you can go to the basal area diameter Q approach for managing uneven age stands. Again, I want to highlight the basic precondition for every close to nature forest management system, every forest conversion which should be successful at the end. You must keep deer population under control. And when I came to our friends in Ukraine, in Lviv, to my colleague at the Ukrainian National Forestry University, he showed me some wonderful forests, and he told me we really have no deer browsing. So the deer population there is so low that they can work with natural regeneration without any protection measures. So fences are unknown in Ukraine, yeah? But fences were still a practice for a long time in Germany in forestry, and in some parts until today. So the deer population, there are interesting economic studies. Germany is losing more than 90 million euros per year as opportunity costs, because young stands are browsed and damaged and have to be re-established again by planting or substitution of the damaged plants. So we have enormous costs or losses every year in Germany, more than 90 million per year. And we have to solve this problem. Otherwise, the trajectory into the future of close to nature and resilient stand is a very hard trajectory and very costly. Close to nature silviculture has a long history, and I could highlight several points here, which I cannot in this lecture, but there are interesting articles on that. I just want to highlight Alfred Möller because he is key to Eberswalde. He was the director of our higher forestry education institution in the 1910s and 20s until 22. And he was, so to speak, the inventor or the promoter of continuous cover forestry. So in Germany, continuous cover forestry goes back essentially on Alfred Möller. And on the right side, I put some elements of close to nature forestry or continuous cover forestry. You see, it's not a single silvicultural system. It's a whole program. It's a philosophy, if you want. It's an approach. It is about selection of tree species of the natural forest cover, creating mixed stands, working with natural regeneration, reducing damages on soil and the remaining stand, retaining stand legacies as deadwood, etc. So that is the core program of all close to nature silviculturists, which are together in ProSilva in Europe. You know this, yeah? ProSilva is the European association of close to nature silviculturists or forest owners. And let's go back to pine and the question of continuous cover forestry. And Möller, when Möller came back from Brazil, because Möller was especially working on fungi, he was a mycologist. He was in Brazil in the 1880s and then came back from the subtropical forest of the German colonies of South Brazil. He came back to Prussia, and then he saw the pure pine stands, and he had in his mind the structured and highly diverse subtropical forests in South Brazil. And then he developed step by step his philosophy of continuous cover forestry. And he found a model. He found a forest district, South Berlin in Sachsen-Anhalt, where a forest owner practiced continuous cover forestry, or a kind of continuous cover forestry in pine stands. It was Friedrich von Kalitsch, which you can see on this stone. And this forest district still today is managed by the State Forest Enterprise of Sachsen-Anhalt, a province in Germany. And they still want to maintain a kind of structured pine forest. But as I told you, continuous cover forestry, the maintenance of pines in the understory of a closed stand is not possible, or is very difficult. So you must have open stand situations. So low standing volumes in the overstory. And then you can work also with a more structured or a multi-layered pine stand. It is possible. And this is done here in Bärentoren, which is this model forest ownership for Möller in the 1920s of the last century. And you can see nicely structured pine stands where the people today work with natural regeneration. We see here our students from Eberswalde several years ago making an excursion to that forest district. You see large pine trees, holdover trees, together with medium-sized pine trees and patches of pine regeneration. So maybe it's not a completely uneven age stand, tree by tree, but it's a patchwise uneven age stand where you have patches of regeneration and you have medium-sized trees, and you may have single or group-wise larger trees in these stands. So it is possible continuous cover forestry, maybe not in the ideal form, not in the intimate mixture, but in a patchwise, in a group-wise mixture. That is Bärentoren. You see there is also admixing with beech, with other tree species. So these are stands which may be more resilient for the future, for these new times which already have come to us than the previous pure and even age stands. And with this, I want to go to my last chapter today, which is the question of how to develop resilient pine forests for the future. And what about the other ecosystem services? It's not only about producing valuable timber or softwood for pulp and paper. It is also about diverse ecosystem services. And I want to address some basic aspects here. The robustness of pine in terms of climate is already addressed. So you can see here the climate envelope of Scots pine for Germany. You see the species range of Scots pine in blue. And then you see a pattern, the climate of Germany now. And you see in red the climate of Germany in the future. and what we can see at the warmer end of the future climate, but also under humid conditions at the warmer end, we have a gap, or we have no overlay of these two envelopes. That means we may face problems or more severe problems with our pine trees. So that is exactly the explanation with a species distribution model, a very simple model, the climate envelope model, why we have these difficulties with pine tree species already in the inner alpine dry valleys, and more also in the central distribution range of pine in northern Germany, for example. Okay, if we now look at silviculture and ask ourselves how we can make our forests more resilient, how we can increase the adaptive capacity. I think it is an appealing model to look at the stages of development of forests and to see where we can intervene. And I hope you agree with me that a central stage in forest management is the regeneration stage. And in the regeneration stage, we can especially manipulate or change the future forest composition and the structure by introducing new species. Just a moment, by help the minor tree species with low vigor in a stand, by introduce maybe foreign tree species from other continents. I will go to that in a few minutes. So the regeneration stage is essential in this conversion process we are at the moment. So we have to be very careful and look at the species composition, but not only that, we also have the task to promote or to build resilient ecosystems. So that is a very difficult discussion, a discussion which is at the moment ongoing in Germany. I think maybe also in other countries. Which ecosystems are the most resilient ecosystems? Basically, are these ecosystems which are managed, so where active management occurs, or are these ecosystems where the forest is left to grow? So that is a current discussion, I think, in many countries in Europe, and it's also addressed by the European Commission or the European Union in its biodiversity and forestry strategy. But that is another story for another webinar. So the regeneration stage is crucial, but we have also options in the intermediate stage. And we can use thinning. Thinning is seen to be an appropriate measure to facilitate the resource distribution to the remaining trees. Because if we remove trees, we improve the water conditions for the remaining trees. And there are already several meta-studies available which show that thinning of Norway spruce, of Scots pine, has a positive effect on drought resistance and resilience. I show an example in a few minutes. And then we come again into the final stage and the initiation of a new forest stand. So what we did in a European project, in a cost project several years ago, we analyzed, many authors from Europe, we analyzed whether the existing concept of close to nature is a suited concept also with respect to climate change. So do the close to nature principles match with the adaptation principles. And what we found out in summary is yes, to a high degree, they match. So we can work with species richness and structural diversity, which is good both for close to nature forest stands or forestry and also for enhancing resilience. The genetic diversity is essential for both goals. The resilience and resistance of individual trees is essential for both goals. So we have with close to nature silviculture, with this approach to work with mixed stands, to work with natural regeneration, to reduce damages at the remaining stand, to emulate old growth attributes with deadwood, etc., with large and old trees. We have an excellent concept in principle to cope with climate change. That is my conviction, and we try to analyze this in some project activities. And the core elements of this resilience I want to highlight just two is first, functional diversity. It's called functional diversity. What does that mean? It's not only diversity of the ecosystem, it's the diversity in functional traits of an ecosystem. So that means the combination of light demanding species and shade tolerant species, the combination of fast growing species and slow growing, the combination of deep rooting species and shallow rooting species. That means to bring together a diverse range of functions, of traits, to be able to cope with diverse impacts of climate change. And even to have these traits more than once, so a redundancy of these traits. So, and 19. That is one point, and this goes together with the principle which is described in silviculture and ecology of ecological insurance. So what we do if we mix stands, if we have different functional traits, if we have a redundancy of these traits, we increase the ecological insurance of our forest stands to damages or to risks. And the second point here in this respect is we should be open at least for introducing tree species from other continents or from other areas. The term which is very often in use here is assisted migration. We know that the natural migration may not be fast enough. So that we assist the migration of different provenances from other provenance areas of a tree species, from even other continents to improve or increase the diversity of our stands and to increase this diversity of functional traits. That is assisted migration. You see the three aspects. It's the assisted population migration, so the expansion of populations northward, for example, in Europe due to warming. Yeah? And the second is the assisted range expansion, ARE, so that a species range can expand due to the change of the climate. And the third is the assisted species migration, which is the introduction of a species from a completely different area, even a continent. And I put three examples here with respect to Scots pine. assisted species migration would be, and this is already done, for example, the introduction of ponderosa pine in Brandenburg, yeah, as another pine species, maybe more robust against climate change. Yeah? Range expansion is the expansion of a species out of its normal range, which already was done in Germany with Scots pine for many decades. And also the provenance question. We have to see, we can use provenances from areas which were already influenced for a longer time by higher temperatures, by less precipitation, and take these more adapted ecotypes and introduce them into our forests. So this is assisted migration together with functional diversity, I think a key element for resilient forests for the future. And if we look at thinning, the second point I want to highlight from these silvicultural measures, you can see that thinning is really proven to be a measure to enhance resilience and resistance. And one common approach here, which is done very often, is the analysis according to Loré. So the resilience and resistance according to Loré. You can see here a study with Scots pine and the preliminary result. You can see the growth performance before the drought event. Yeah, drought event was 2003. And then you can see the curves in different years, how they recovered after drought. And what is the influence of thinning? And what we can see is a low resistance in 1976 and 1991, but higher resilience at young ages. The resilience is the recovery. So species may not be very good in resisting, but they come back to the former growth level and they recover. But we can also see that with subsequent drought years, the resilience is declining here. So the resilience was quite good at the beginning, at younger ages, but is declining with more and more drought years, which is a hint that the whole system may not be so robust. That leads me to my final considerations. And that is how can we cope with these damaged areas, which we see especially also here in Germany. This is a slide from an area between Berlin and Leipzig, where Scots pine stands, sometimes pure, sometimes a little bit mixed, were heavily damaged due to the consecutive droughts in 2018 to 20. And now we have clear cuts or cleared areas because there was salvage cutting. Yeah, the people tried to salvage a large part of the timber. And the huge question now is how can we make reforestation? And I would take the term here, restoration. It's really an activity of restoration, which we have to do here. How can we restore these areas? Should we leave nature alone? Should we wait and hope that nature is the best, the natural development is the best pathway? Or should we actively intervene into these areas and invest? Which tree species should we plant? Should we combine natural succession with planting? In which degree? How long should we wait for natural succession? Excuse me. So these are exactly the questions many forest owners have at the moment when they try to restore these areas. And I just give you some slides and some ideas on that. Of course, for the state forests, there are some rules, some principles how these forests should be restored. Of course, they should be restored by mixtures, mixed stands, and pine will reduce. We will have more broadleaf trees. Maybe we will still have some pines in these stands, but not as much as in the past. The preferred technique is natural regeneration, if it works. Sometimes we must assist with soil preparation, soil scarification, and we have also to consider already in this stage measures of nature conservation. For example, forest margins, diverse species composition at forest margins, habitat trees, etc., keeping dead wood on the ground, etc. So these are the principles of reforestation after damages under very difficult conditions. And if you look at these sites, you can see this is a former forest. So this is a forest which was damaged in 2018, 2019, and then salvaged. And now it's the time after according to the forest law, after 3 years, to reforest the stand again, to plant if there is no natural regeneration. And that is very difficult. So the obstacles are obvious. It's grass, yeah? Thick grass layers. It's mice, for example, or insolation, high radiation, a harsh microclimate, especially for late successional tree species, beech, etc., silver fir. They cannot be planted on large open areas due to frost sensitivity. So it's heat. So these are really difficult conditions, but it's my conviction that in these areas, if we want to have forests, we have to invest and have to actively manage these areas. Of course, to use the natural possibilities, but we have to actively manipulate or manage these areas in order to initialize a forest development for more resilient stands here. So if we wait, we can expect something, of course. We will expect, for example, pioneer species such as aspen. Aspen is very common on these areas, aspen or birch. But what about the target tree species? Of course, we could be satisfied with an aspen stand on a mid-term, on a long term. But what about stands maybe with more diverse ecosystem services? So it's a question of soil preparation as soft as possible, but as intensive as necessary. What we should, of course, consider is to leave legacies, to leave elements of the former stand. So dead trees, standing dead trees, or coarse woody debris, so lying dead wood. These are important elements for safeguarding biodiversity in these areas. So dead wood is highly acknowledged as a magnet of diversity, of different insects. There are interesting studies that hundreds of insect species are especially dependent on dead wood. So this is important that we identify site-adapted individual solutions for these areas, of course, with some principles, but site-adapted solutions And experts or very experienced people, they say every large-scale damaged area is a single situation. Yeah, so we must look really at the site conditions in the area. Okay, that means that we will also work, and that is my pledge, that we also should take into account exotic tree species, not on a large scale, but sometimes as groups, as admixtures in stands with native tree species, because these species can include additional traits in these forest ecosystems. So that means Scots pine management is not only about producing pulpwood or valuable timber production. Scots pine management can be very attractive for restoration purposes, that is the fixation issue. Scots pine management can be interesting for non-wood forest products such as mushrooms or berries, and there are nice studies about that. The admixture of broadleaf trees is very essential for the water household, for the infiltration rates to the groundwater in these areas. Scots pine forest can be important for carbon storage, of course, and we can optimize carbon storage in pine stands together with the product storage pool. So we know that we have 3 pools, the forest pool, and then we have the products pool of carbon stored in a durable product. And finally, we have the substitution of more carbon intensive products by wooden products. So we have this whole issue. We have the biodiversity issue. So it is clear that these diverse ecosystems or these specific ecosystems, they come not automatically with the production of timber. That was to emphasize where we want to produce, where we can provide other ecosystem services, where we lay an emphasis on biodiversity, etc. And this is possible, and we have the concepts for this. And many of us may remember that a few years ago there was activities to describe and to go into detail into a concept which is called integrative forest management. The IFM, integrative forest management. There was an EFI project called Integrate, which was the basis of that final book, which was published. And integrated forest management is a concept where you can provide different ecosystem services while keeping an emphasis on production. So while actively manage forests, but with the consideration also of non-managed areas, smaller non-managed areas of 5 or 10%. Of course, there's room for these elements in such an integrative forest management strategy. So that is my conclusion at the end. Before I really come to the end, I just want to mention, of course, there are alternative pine species suitable for our stands in Europe. They are already here. And we were pine on restoration areas in the mining area in southern Brandenburg, for example. And in the alpine areas, we have different pine species in the close to nature forest there. So I want to close with some basic messages, take-home messages or conclusions concerning Scots pine. It's a very important conifer tree species in Europe, in the forests of Germany. It has pioneer species characteristics. It is less competitive and thus restricted to marginal sites under competition. Yeah, it is normally quite robust, but becoming more and more susceptible to pests, to drought in the last years. So we have to acknowledge that also Scots pine it's a main tree species in Germany, belongs to the species which came under stress in the last years. And yeah, that is something we have to admit. The future of Scots pine management is not in pure stands, not on large areas, not regenerated with clear cut and planting, but in mixture with oak and beech, regenerated with natural regeneration, maybe enriched with exotic species such as Douglas fir. We should keep in mind that Scots pine can be a timber, can be a valuable product. So it's not only pulpwood. Of course, we have this coupled production in forestry, but high value timber production can be an interesting, economically interesting option for private or other forest owners. Scots pine is difficult to be managed in continuous cover forest systems, but it's possible. So I think, of course, Scots pine has a good future, or has still a future in forestry in Germany, but it is a species which will be gradually reduced. That is at least a fact. So with these take-home messages, maybe I want to thank all of you for your participation, for your interest, and I hope that we have further interesting pine webinars, and I'm still here available for some questions. But first of all, I thank you very much for your interest and for your patience. Thank you.
We thank you for your generosity, for sharing all this knowledge. And this presentation was not only a compact overview of Scots pine in Central Europe, but I would argue that Peter presented us to the most important debates and conversations that we are currently having in Europe. And it was interesting for me as a forester focused on pine, how almost you were apologizing for having pure stands and pure conifer stands. And I do believe that in order for us to have a more resilient forest, we do need to have to diversify. And that is definitely the way, as you have shown us, because it has both economic and also ecological advantages. But also these pioneer robust species will always have a key role in a world where increasingly we have disturbances, right? And so they will play an important role in restoring ecosystems. I was reading the questions and the comments, and most of them were really commenting, even though some in the form of questions, but most of all comments that made it the conversation even more interesting. So I'm not sure if you agree, but maybe we can end the webinar since
Yes.
we are already half an
Yeah.
hour
Yeah.
after the schedule that
Yeah.
we had advanced. So I would like to thank all of our audience. You will be receiving soon Peter's presentation and also a link for the recording so that you can review again this webinar. I thank also IUFRO and thanks you for being here, and please let us know if you are interested in this webinar cycle. We will invite you for the future webinars in these cycles. So thank you very much to all of you and see you soon. Bye.
Thank you.